my good friends. My name is Teteje Kepsi Richard. Welcome to my online teaching. Our discussion on numerical and computational method and final difference for that matter will be on error detection and correction. If I tell you one of the values of y here is in error, will you be able to tell me the one that is in error? Today, before the video ends, we will learn how to determine where the error occurs and correct that error. So we saw some sample question where the error occur will be given to us in the question. Ours is to correct that error. Then we also solve another sample question where the error occur will not be given. Our obligation is to determine where the error occur. Then after that, we correct it. This will be a very interesting engagement, so please come along. So let's say we have a set of values for x as x0, x1, x2, x3, x4, x5, x6 up to x9, and that of y is y0 up to y9, and we happens to know that an error occur at y5, so we add that error to y5, so ESLA to the y5. So now we'll find the difference. So the difference between y1 and y0, let's say, is del y0. The difference between this and this will be del y1. The difference between this and this will be del y2. And the difference between this and this should be del y3. And the difference between this and this, that's y5 minus y4, will be del y4 plus ESLA or plus error. Now, when we subtract this from this, we have y6 minus y5 will be del y5, then minus error. Then this from this will be del y6, this from this will be del y7, this from this will be del y8. So also, we find the second difference, that's del square y. So this, the difference between this and this will be del square y0. The difference between this and this will be del square y1. The difference between this and this, that's del y2 and del y3, will be del square y2. Then this from this will be del square y3, then plus error. Then this from this will have del square y4, then error minus error, that will be minus 2 error. Then the difference between this and this, that's y, so that will have del square y5, then plus error. Then the difference between this and this will be del square y6, then this and this will be del square y7. Now let's find the fourth difference, the third difference, that's del square y. So the difference between this and this will be, so that's the third difference. So the difference between this and this will be del cube y0. This and this should be del cube y1. And the difference this from this should be del cube y2, then plus error. Then the difference, once we subtract this from this, we'll get del 3 y3, then minus 2 error minus error will be minus 3 error. Then the difference, once we subtract this from this, we'll get del 3 y4, then error minus 2 error will be plus 3 error. Then this from this, we'll get del cube y5, then minus error. Then this from this will be del cube y6. I hope you get that. Let's find the last difference, which is the fourth difference. And we happen to know that maybe polynomial which connect x and y is to the fourth power. So we find the difference between this and this will be del 4 y0. Then this and this will be del 4 y1. Okay, this from this will be del 4 y1 plus error. Then this from this will be del 4y2 then minus 4 error. Then this from this will be del 4y3 minus, okay, plus 3 error minus negative 3 error will be plus 6 error. Then this from this will have del 4y4. Then error minus 3 error, that will be minus 4 error. Then this from this will be del exponent 4y5, then plus error. I hope you get that. Now let's see what happened. Remember the error occurs here. So now having traced our values to where the errors is, so you can see where the epsilon, which is the errors is where we trace it to where the error occurs. Remember we said the error occurs at y5. Now we are going to write the coefficients of the error at where they occur and see what happens. So the coefficient here is 1. So we write it here 1. The coefficient here, please let's ignore the negative for now. 1, 1. So look at it, 1, 1. Then when we come here, that's 1, negative 2, 1. So let's ignore the negative for now. So we have 1, 2, 1. Then the next place, which is here, see is 1, negative 3, 3, negative 1. So we can say 1, 3, 3, 1. Then the next one, which is here, see is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And this is positive, positive, negative, positive, negative, positive, positive, negative, positive, negative, positive, negative, positive, negative, positive. I hope you get that. Now what is this? You can realize this is forming a Pascal triangle. A Pascal triangle. Where this is to degree 0, this is to degree 1, degree 2, degree 3, then this is degree 4. I hope you get that. So having identified that the errors occurring is just the coefficients of a Pascal triangle expansion, then we don't have problem. So if we are told where the error occurs, it is easy to find it. So we find a sample question where we are told where the error occurs, then we find that error and try to correct it. Or since we are told where it occurs, we try to correct it. So let's solve our first example. Here is the value of a polynomial of degree 5 are tabulated below. If f of 3 is known to be in error, we should find the correct value of the f of 3. So what do? We have to construct a difference table. Please do well to check out my videos on how to construct difference table on YouTube. So this is how the table will look like. So since the f of 3 is said to be in error, we add that error to that. So we add the error to this value. So the error, which is epsilon, to that value. What do? Remember they say the polynomial function is to degree 5. So we need to find the difference up to the 5th difference. I hope you get that. So we find our first difference. So del of y. What do? 2 minus 1, that's 1. Then 33 minus 2, that will be 31. Then 254 plus error minus 33 will give me 221 plus error. Then this 1025 minus 254 plus error will give me 771 minus error. Then this from this will be 2101. And this 7 times 777 minus 3 times 126 will give me 4651. So we have found the first difference. Now we find the second difference, which is del square of y. So we find our second difference. 31 minus 1 will be 30. Then 221 plus error minus 31 will give me 190 plus error. Then 271 minus error minus 221 plus error will give me 550 minus 2 error. Then this from this, that's 2101 minus 771 will give me 1330 plus error. Then this from this will be 2550. So we'll find our third difference, which is del cube y. So I'll subtract 30 from this, we'll get 160 plus error. Then we'll subtract 190 from 550. That's 190 plus error from 550 minus 2 error. We'll get 360 minus 3 error. Then this from this, we'll get 780. That's error minus 2 error, that will be plus. So 780 plus 3 error. Then this from this, we'll get 1220, then minus error. Now find the fourth difference, which is del 4y. Now I'll subtract this from this. That's 360 minus 160. We'll get 200. Then 3 minus 3 error minus error will be minus 4 error. Then this from this, that's 780 minus 360. We'll get 420 minus, 420 plus 6 error. That's 3 error minus negative 3 error. That will be plus 6 error. Now subtract this from this. We'll get 440. That's 1220 minus 780 will be 440. Then minus error minus 3 error will be minus 4 error. Remember, our polynomial function is to 5th degree. So we'll find the 5th difference. So del 5y. Now, this from this, that's 420 minus 200. That will be 220. Then 6 error minus negative 6 error. That will be plus 10 error. Then we'll subtract this from this. 440 minus 420. We'll get 20. Then minus 4 error minus 6 error will be minus 10 error. Now, having known that the polynomial is to 5th degree, it implies that the constant occur at the 5th degree. So these values are the same. So we can compute that value. So we can say 220 plus 10 error is equal to 20 minus 10 error. We group like 10 error plus 10 error epsilon, which is 20 minus 220. 10 error plus 10 error, that will be 20 error. Then 20 minus 220, that will be negative 200. We divide both sides by 20. Here by 20, our error will be equal to negative 10. So having find the error, remember our f of 3 was in error, and the correct one now is 154 plus error. So our correct f of 3 is equal to 254 plus the error. So this will be 254 plus negative 10, which is the error. That will be 254 minus 10. So the correct f of 3 is equal to 244. I hope you get that. So we are able to correct the error, having told where the error occurs. Now, if we are not told where the error occurs, how do we dictate where it occurs and correct it? So let's solve our second question. They say in the following table, one value of y is incorrect and y is a cubic polynomial of x. Construct a difference table for y and use it to locate and correct the wrong value. So you can see that the wrong value is not given to us. Our task is to locate it. Then after that, having located it, we correct it. So what do? We need to construct a difference table to look like this. Then we find the difference. Remember, the polynomial is to the cubic polynomial. So we find out to the cubic polynomial. Then we'll try to locate the error and correct it. So find the first difference, which is del y. So this from this, 0 minus 0, that will be 0. 1 minus 0, that will be 1. 6 minus 1, that's 5. 6 minus 24 will give us 18. 60 minus 24, that will be 36. Then 60 minus 120 will be 60. And 210 minus 120 will give us 90. That's the first difference. We find the second difference, which is del square y. 1 minus 0 is still 1. 5 minus 1, that's 4. 5 minus 18 is 13. Then 18 minus 36, that will be 18 again. 60 minus 36, that's 24. And 90 minus 60, that's 30. We find the third difference, which is delta cube y. 4 minus 1 will be 3, sorry. 13 minus 4, that will be 9. 18 minus 13 is 5. 24 minus 18 is 6. 60 minus, 90 minus 60 is 30. Then 24 minus 30 will be 6. I hope you get that. Then remember, this is a cubic polynomial function. That means when we find any difference beyond that, it must be 0. So here must be constant. However, look at it, it's not constant. You can see this is 6, 6. That means it's actually 6, 6. The rest are in error, if you get a clue. However, let me find the fourth difference. All must be 0, but because one value is in error, it's affecting each of them. So 9 minus 3 will be 6. 5 minus 9. 5 minus this 9 will be negative 4. Then 6 minus 5, that will be 1. Then 6 minus 6 is 0. So you see the whole fine, only 1 is 0. That means all these values are in error. So how do we trace the error? So as having said that, we said that all these three values are in error. Since anything beyond the cubic should be 0, then all these are in value. Or when we find to the cubic, it must be constant so that you can see that this and this are correct. The rest are in error. Or people say that after you find up to the difference beyond the cubic, the highest value there, you trace it. Its corresponding value there is in error. So we can say that f of 2, which is equal to 1, is in error. Is in error. Or is incorrect. Is incorrect. So the one here is supposed not to be 1. Which value is it? So we remember we said that value plus the error. How do we determine the error? Since this is up to the 4th power, we find the Pascal triangle for that. Remember, Pascal triangle will be 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, then 1, 1, 4, 6, 4. So you can see that this is power 0, power 1, power 2, power 3, then power 4. So these values here must be the value minus error. That's, remember, this is plus, minus, plus, minus, plus. However, since these are only 3 values, we take the last three values. That means the first and the fourth are affected by the error. So the last 3 we have plus, minus, plus. So we can say the value here will be 6 minus 6, 6 plus 6 error. Then here will be minus 4 error using this one. Then 1 plus error. What will be the value here that must okay? All the value there must be 0. So we equate them to 0. Now any one of them, you get the same value for the x-lar, which is the error. Then, when we find the value of the error, we just add it here. Then we get the correct value of f of 2. So with any of them, remember this, we have 6 error equal to -6. Then this will be, we divide both sides by 6. You see that the error will be -1. Here too, we can say -4 error is equal to 4. When we divide both sides by -4, you can see that we'll get error to be -1. The same way here, we have say error is equal to 0 minus 1, which is -1. So any one of them, you get error to be -1. So the error is actually -1. So the correct value will be equal to 1 plus the error. So that will be 1 plus -1, and that's 0. So the correct value is 0. That means this place actually must be 0. That's the value here must be 0. I hope you get that. At times, haven't found beyond the cubic, if it is a cubic polynomial, haven't found beyond that, you will not get any of these values being 0. How will you be able to locate the error, and how can you correct it? So at times, if we find beyond the given degree of the polynomial, we must get 0. But at times when we find it, we don't get 0. That means none of those values will be equal to 0. Then we have to use another idea to solve that. So, for instance, if we have this difference table, look at it very well. And I try to find the average of all these values. I must get to. Look at it. So we can say the average of del square y. Remember, this polynomial is a quadratic polynomial because the second difference is constant. So we can say it's equal to 2 plus 2 plus 2 plus 2 all over the average 1, 2, 3, 4. So all over 4. 2 plus 2 plus 2, that's 8. 8 divided by 4 will give us 2. That means when we reach the degree of the polynomial, we find the difference up to the degree of the polynomial, and we find the average there, the value we get, let's say when we get 2, that means the value 2 there is correct. The rest, which is not 2, are in error. I hope you get that. When we find 3, the value of the 3 there is correct. The rest of the value are in error. So we are going to use that idea to solve our next question. So before we solve our third video, please remember to subscribe to my YouTube channel. If you are here to like, comment. Your comment keep me going. Please watch. If you watch my video, remember to like it. This will motivate me to record more videos for you. The question says that in the following table, one value of y is incorrect and y is a cubic polynomial of x. Construct a difference table of y and use it to locate and correct the error. So remember, they say we have to construct a difference table. So we need to construct a different table. We locate the error and use it to correct the error. So we need to construct a difference table. Please check out my videos on how to construct difference table on YouTube. So we have del y. So 21 minus 25, that will be -4. 18 minus 21, that will be -3. 18 minus 18, that was 0. 27 minus 18, that will be 9. 45 minus 27, that will be 18. Then 76 minus 45, that will be 31. Then 123 minus 76, that will be 47. Now we'll find the second difference. Remember, they say it's a cubic polynomial. So del square y. So -3 minus -4. See, -3 minus -4. That will be -3 plus 4, and is equal to 1. So this will be 1. 0 minus -3, that will be 3. 9 minus 0, that's 9. 18 minus 9 is 9. 31 minus 18, that will give us 13. Then 47 minus 31, that will give us 16. Then we'll find the third difference. Del cube y. 3 minus 1 is 2. 9 minus 3 is 6. 9 minus 9 is 0. 13 minus 9 is 4. Then 16 minus 13, that will give us 3. Now let's find the and see if we get any of them to be 0. See, 6 minus 2, that's 4. 0 minus 6 is negative 6. 4 minus 0, that will be 4. And 4 minus 3 is 1. You can see that all of them, none of them is what? Is 0. So you can't use the idea of the Pascal triangle of errors to solve or locate the error. Rather, we need to find the average. Remember, if this is a cubic polynomial, once we add all these things, we'll find the average of this. It must produce the correct constant here. So having find the average of this, it will produce one of these numbers. So we will detect that that number is correct or that value is correct and the rest are in error. Then we take it from there. So we find the average of del cube y. That will be equal to 2 plus 6 plus 0 plus 4 plus 3 divided by 1, 2, 3, 4, 5. So divided by 5. 2 plus 6 is 8. 8 plus 4 is 12 plus 3. That will be 15. 15 divided by 5 is 3. So you can see it produces 1. That means this value is correct and the rest are in error. So we just trace it and find that error. So as we said, the 3 is correct and the rest are in error. When we trace it, you see that this 18 here is in error. So initially we did not draw the line very well. So you must draw it diagonally. I hope you get that. You must draw it diagonally. That's why you'll be able to determine it very well. Or people also say that locate the biggest value here and trace it to it. So they see that the biggest value corresponds to the 18 as I said first. So the wrong value of y is 18. So if the wrong value is 18, what's the correct? The correct one, the correct value will be equal to the 18 plus the error or the epsilon. How do we find the epsilon? So the average, which is the average of del cube y, okay? Then plus the error will be equal to the first wrong value here, which is 2, will be equal to 2. What's the average? The average is 3. So 3 plus the error will be equal to 2. The error will be equal to 2 minus 3. The error is negative 1. So we see that the error is negative 1. So the correct value will be equal to 18 plus negative 1. And 18 plus negative 1 will be 17. So the correct value is 17, not 18. So it should be 25, 21, 18, 17, 27, 45, 76, 123. If you do like that, substitute that, you see that all the values here will be 3 throughout. So we have been learning how to detect errors in our difference table and how to correct it. We'll end it here today. Please remember to subscribe to my YouTube channel again before you sign out. Until we meet again, my name is Kepsi Richard.